Hi everyone, we're Team 7 and today my teammates Latish, Krishna and I will be presenting our work on the Airbnb database management system. And Latish, can you switch to the next slide? So our agenda for today's presentation is to first go over the scope and objectives of our multi-model database project. Then we'll be talking about the architecture design as well as the entity relationship diagram. Then we'll further be explaining of how we integrated and ingested the entire data. And finally, we'll present the visualization and analysis reports that we were able to generate. Next. So the scope and objectives of our project were to generate reports to study the Airbnb statistics in the US, also check the number of listings by state, city, and neighborhood, and also perform a cost metric analysis segregated by different cities in the country and determine the most common type of properties being used as Airbnb spots in the US. Next. So here is what the architecture for our multi-model database system looks like. We took our sample of Airbnb data set from Open Data Soft in Excel. So this data was scraped off from the official Airbnb website. And so what we dealt with wasn't user specific. That is, it did not have user and bookings data. So once the data was retrieved, we used Talent as a tool to perform the data ingestion and integration and created pipelines to perform simple ETL processes and automate them to finally store and maintain the data in Microsoft SQL Server, which we used as our main database, where we manipulated and queried this data to finally generate reports in Power BI. Next. So to create a multi-model database system and be able to manage this data coming from different sources, we segregated our relational, graph, and document tables in a manner that made it easier for us to link each table to generate meaningful reports. Here you can see the relational tables were hosts, reviews, costs, amenities, graph were location, property, and document was availability. I'll further be explaining them in the coming slides. Next. So here is the entity relationship diagram for the relational as well as document tables. We use this to manage the main table property, which you can see in the middle, which we use to store data pertaining to Airbnb properties, such as property type, features, number of bedrooms, beds, baths, and listing URL. So this table was directly linked to all other relational tables like host, which stored the information of the person who owned the property, having one-to-many relationship with the main table. That is, every host can have multiple properties. The same way we had tables such as costs, reviews, amenities, on the basis of which we created our reports to help customers skim through the listings. Now, these tables share one-to-one relationship with the property table such that the key attributes include property ID, which is the primary and foreign key for these tables. Next. So moving on, here we were able to collect the snapshots of our create table queries for our relational tables. Now, the first one being host with 9 attributes that stores the details about the owner of an Airbnb property. Key attributes include, like you can see, the host ID, which is the primary key, name, location, response time, acceptance rate, and listing count. Then we have the reviews that consists of several reviews given by the guests that included attributes such as rating count, average ratings, average cleanliness ratings, accuracy, reviews per month for a particular property. Then we have the cost table that consists of the price that is charged for staying at an Airbnb property with 7 attributes. So the key attributes include the property ID, which is the primary and foreign key here, price per night, weekly and monthly price, and cleaning fee, basically all the costs that are incurred while renting out our stay. Then we have the amenities table that consists of all the amenities available in a particular property. We have stored each amenity corresponding to a property by providing the property ID in a single row. Next. So coming to the graph tables, we found that a to and from relationship existed between location and property. So we use these two tables as node, where the location table has all the data associated with the location of the property, which includes the country, the state, street, and neighborhood. And the the located at table has been created as an edge with edge ID as the primary key and from into data which outputs in JSON format. Next. So here we have our document table availability, which is implemented as a document type that provides and displays details about booking an Airbnb property while describing attributes such as the minimum nights, the maximum nights, calendar updated, and whether or not it's available for 30, 60, 90, or 365 days. So that was it on the create tables. And now Latish would take over to explain the data ingestion and integration part using Talend. Over to Latish.
Hi, everyone. So for this specific project, we have used multiple tools for data integration, ingestion, and refresh. So the tools that we used were Talend, some custom SQL code, and Windows Task Scheduler. Let's move on to data integration and ingestion. Okay, so initially we have some tables that are dependent on some other tables and some tables that are independent. For independent tables, the mapping was pretty easy. It was just loading up our TSV files that we have, that's the tab separated value, and just mapping the fields into the destination table. For example, here we have the location table that is being loaded using a simple ETL job. Then we have some dependent tables, which are dependent on some other tables. For example, we have the property table, which has the host ID and the location ID as foreign keys. So in order to do that, we have to load the host table and the location table before that. And then we go ahead and join it with the source file, and we go ahead and load the property table. This is what the mapping looks like in the Talend workflow. So we are using an inner join and a unique matcher, and then finally mapping everything in the correct location. And this is how the data looks for our main property table. So we have the location ID, host ID, property type, square foot, guests included, and some other data. For some tables required some data to be cleansed and normalized. So we had some data that was comma separated. So we had multi-valued attributes and some null values. So before going ahead and actually loading the data, we had to kind of remove the null values, replace some brackets, and in the end, we needed to kind of normalize the data. So we use simple ETL objects, so Talend objects to go ahead and do that. And this is how our final data looks in the amenities table. Moving on to the document table, so we had a single XLSX file that had multiple rows that we needed to load as JSON because we couldn't get the JSON source file. So this was the code that was used to go ahead and concatenate all the rows in a way so that it loads as a JSON file. This is how our availability table looks in the document table. Moving on, for connecting all the nodes, we had one table, a graph edge table, that was located at table. In order to go ahead and actually connect both of the tables, connect all the rows that were relevant, we use a custom SQL code where we are using some part of a dynamic SQL and a while loop in order to connect both the tables, both the nodes with the edge. This is how it looks. This is how our located at tables looks in our database. Moving on, now we are done with the data ingestion. Now we need to kind of move to data refresh. In order to initiate the data refresh, we had to go ahead and create a master job first. So this is how a master job looks. So if we run this master job, it will load and update all the tables that we have in our database. Some dependency was there, just like I mentioned before. Property table is dependent on host and location table, so it had to be run in a sequence. Now, once we have the master job, we go ahead and build the job so that we get the .bat file, which we can go ahead and schedule in the Windows Task Scheduler to be run at a specific time, which would finally give us a CMD prompt notifying us that this job has started running or run successfully. So that's about it for data ingestion and data refresh. I'll pass it on over to Krishna to explain the data visualization part.
Hi everyone. So for our visualization, we have used Microsoft Power BI for creating reports and dashboards to highlight the trends and outliers. Moving on to our first report. The next slide, Latish. So in our first report is a map visualization that shows the number of Airbnb listings filtered by location in the United States. We have also displayed the most common property types in each state in the form of a pie chart inside the map visualization. For example, in California, the most common property type is a house. In second report, we displayed the reviews received by Airbnb properties, which consist of ratings, rating counts, cleanliness ratings, location ratings, etc., along with the cost, location, listing, and picture URL. We can click on the listing URL that would redirect us to the Airbnb website. Moving on to the next report, this visualization is used to determine the average cost of an Airbnb property present in different locations in the US. As we can see, Maryland has the highest average price, whereas New Jersey has the lowest. Next, we we have a pie chart that represents the ratio of different Airbnb property types. We can use this to determine the most common and the least common type of properties booked. Houses and apartments are widely used, whereas huts or lighthouses are not very famous. And finally, our last report uh, is used to visualize amenities along with the maximum and minimum nights a property can be booked. We can also look at the property by clicking on the respective URL links. And that's the end of our presentation.